Explain decision tree algorithm in detail. Question number 11. A decision tree is a supervised machine learning algorithm mainly used for regression and classification. It breaks down a data set into smaller and smaller subsets while at the same time an associated decision tree is incrementally developed. The final result is a tree with decision nodes and leaf nodes. A decision tree can handle both categorical and numerical data. The term classification and regression tree, that is CART analysis, is an umbrella term used to refer to both of the above procedures. Some techniques, often called ensemble methods, construct more than one decision tree. Boosted trees incrementally building an ensemble by training each new instance to emphasize the training instance's previously mismodeled. A typical example is ADA Boost. These can be used for regression type and classification type problems. Bootstrap aggregated or back decision tree, an early ensemble method, builds multiple decision tree by repeatedly resampling training data with replacement and voting the trees for a consensus prediction. A random forest classifier is a specific type of bootstrap aggregating. Rotation forest, in which every decision tree is trained by first applying principal component analysis on the random subset of the input features. A special case of decision tree is decision list, which is one-sided decision tree so that every internal node has exactly one leaf node and exactly one internal node as a child, except for the bottommost node, whose only child is a single leaf node. While less expressive decision lists are arguably easier to understand than general decision tree due to their added sparsity, permit non-greedy learning methods, and monotonic constraint to be imposed. Notable decision tree algorithms include ID3 iterative dichotomizer 3, C4.5 successor of ID3, CART classification and regression tree, chi-square automatic interaction detection, CHAT, CHAIT, performs multi-level splits when computing classification trees, MARS, extend decision tree to handle numerical data better, conditional inference trees, statistics-based approach that uses non-parametric tests as splitting criteria, corrected for multiple testing to avoid overfitting. This approach results in unbiased predictor selection and does not require pruning. Question number 12. What are entropy and information gain in decision tree algorithm? So there are a lot of algorithms which are employed to build a decision tree. ID3 iterative dichotomizer 3, C4.5, C5.0, CART classification and regression trees, to name a few. But at their core, all of them tell us what question to ask and when. The below table has color and diameter of a fruit and the label tells the name of the fruit. How do we build a decision tree to classify the fruits? So there are three columns named color, diameter and label. Color green, yellow, red, yellow, diameter 3, 3, 1, 1, 3, label apple, grape, lemon. Here is how we will build the tree. We will start with a node which will ask a true or false question to split the data into two. The two resulting nodes will each ask a true or false question, again to split the data further, and so on. There are two main things to consider with the above approach. Which is the best question to ask at each node? When do we stop splitting the data further? Let's start building the tree with the first or the topmost node. There is a list of possible questions which can be asked. The first node can ask the following questions. Question number 1. Is the color green? Is the color yellow? Second question. Third question. Is the color red? Fourth question. Is the diameter greater than equal to 3? Fifth question. Is the diameter greater than equal to 1? Of these possible set of questions, which one is the best to ask so that our data is split into two sets after the first node? Remember, we are trying to split or classify our data into separate classes. Our question should be such that our data is partitioned into as unmixed or pure classes as possible. An impure set or the class here refers to one which has many different types of object. For example, if we ask the question for the above data, is the color green? Our data will be split into two sets, one of which will be pure, the other will have a mixed set of labels. If we assign a label to a mixed set, we have higher chances of being incorrect. But how do we measure this impurity? Then Gini impurity and information gain comes into picture. CART, classification and regression trees, uses Gini index classification as metric. The Gini impurity metric measures the homogeneity of a set of items. The lowest possible value of GI is 0.0. The maximum value of GI depends on the particular problem being investigated but gets close to 1. Suppose, for example, you have 12 items: apple, grapes, lemon. If there are 0 apples, 0 grapes, and 12 lemons, then you have minimal impurity. This is good for decision tree. And GI is equal to 0. But if you have 4 apples, 4 grapes, 4 lemons, you have maximum impurity, and it turns out that GI is equal to 0.663. I'll show example calculations. Maximum GI,
that is Guinea impurity.
apple, grapes, lemons. Count 4, 4, 4. Pi is equal to P is equal to 4 by 12, 4 by 12, 4 by 12 is equal to 1 by 3, 1 by 3, 1 by 3. GI is equal to 1 minus 1 by 3 to the power 2 plus 1 by 3 square plus 1 by 3 square. 1 minus 1 by 9 plus 1 by 9 plus 1 by 9. That is equal to 1 minus 1 by 3 is equal to 2 by 3. So GI is equal to 0.667. When the number of items is evenly distributed, as in the example above, you have maximum GI, but the exact value depends on how many items there are, a bit less than maximum GI. Let's take another example where count is equal to 336. So probability is equal to 3 by 12, 3 by 12, 6 by 12. 1 by 4, 1 by 4, 1 by 2. So GI is equal to 1 minus 1 by 4 square plus 1 by 4 square plus 1 by 2 square. So 1 minus 6 by 16 is equal to 10 by 16 is equal to 0.625. In the above example, the items are not quite evenly distributed and GI is slightly less. Which is better when used for decision trees? Minimum GI, count is equal to 0, 12, 0. Probability is equal to 0 by 12, 12 by 12 and 0 by 12. So probability is 0, 1, 0. GI is equal to 1 minus 0 to the power 2 plus 1 to the power 2 plus 0 to the power 2. So total is equal to 1 minus 1 is equal to 0. Here GI is equal to 0, that is minimum GI. Suppose there are S number of classes, then Pi be the position of elements of class I. Gini impurity would be II P is equal to 1 minus summation of Pi square from I is equal to 1 to I is equal to S. The Gini index is not at all the same as different metric called the Gini coefficient. The Gini impurity metric can be used when creating a decision tree, but there are alternatives, including entropy information gain. The advantage of GI is its simplicity. Information gain. Information gain is another metric which tells us how much a question unmixes the labels at a node. Mathematically, it is just a difference between impurity values before splitting the data at a node and the weighted average of impurity after the split. For instance, if we go back to our data of apples, lemons, and grapes and ask the question, is the color green? True or false? On true side, we see that impurity is 0. On false side, we see impurity is equal to 0.62. So information gain is equal to 0.64 minus 4.5 into 0.62 plus 1.5 into 0 is equal to 0.144. The information gained by asking this question is 0.144. Similarly, we can ask another question from the set of possible questions. Split the data and compute information gain. This is also called recursive binary splitting. Question: is the color gain information gain 0.14? Is diameter greater than or equal to 3? Information gain 0.37. Is the color yellow? Information gain 0.17. Is the color red? Information gain 0.37. Is diameter greater than or equal to 1? Information gain 0. The question where we have the highest information gain is diameter greater than or equal to 3 is the best question to ask. Note that the information gain is same for question is the color red. We just pick the first one at random. Repeating the same method at the child node, we can complete the tree. Note that no further questions can be asked which would increase the information gain. This is diagram. Also note that the rightmost leaf which says 50% apple and 50% lemon means that this class cannot be divided further, and this branch can tell an apple or lemon with 50% probability. For the grape and apple branches, we stop asking further questions since the Gini impurity is 0 for those. Entropy and information gain ID3. ID3 iterative dichotomizer 3 uses entropy function and information gain as metrics. There is a table where predictions and target are given. In predictions, we see outlook, temperature, humidity, and windy, and in target, we use hours played. So, outlook sunny, overcast, rainy. Sunny, windy, overcast 46.3, rainy temperature, false, windy false, then 47.7 hours. If true, then 26.5 hours. Temperature if cool, then 38 hours. If temperature is hot, then 27.5 hours. If temperature is mild, then 41.5 hours. If the sample is completely homogeneous, the entropy is 0, and if the sample is unequally divided, it has entropy of 1. So entropy, this is formula of entropy is equal to minus P log P to the base 2 minus Q log Q to the base 2. So this is formula of entropy. To build a decision tree, we need to calculate two types of entropy using frequency tables as follows. A. Entropy using the frequency table of one attribute. ES is equal to summation I is equal to 1 to C minus Pi log Pi to the base 2. For example, we have to find the entropy of play golf where S is equal to 9 and no is equal to 5. So entropy play golf is equal to entropy 5 comma 9. Entropy 0.36 comma 0.64 is equal to minus 0.34 log 0.36 to the base 2 minus 0.64 log 0.64 to the base 2 is equal to 0.94. This is how we find entropy using frequency table of one attribute. In this entropy formula, P is probability. So here 0.36 is probability of no and 0.64 is probability of S. B. Entropy using the frequency table of two attributes. E t comma x is equal to summation of C belong to x PC into EC. Information gain. The information gain is based on the decrease in entropy after a dataset is split on an attribute. Constructing a decision tree is all about finding attribute that returns the highest information gain, the most homogeneous branches. Step 1. Calculate the entropy of the target. Entropy play golf is equal to entropy 5, 9. Entropy 0.36, 0.64. So entropy comes out as 0.94. Step 2. The data set is then split on different attributes. The entropy for each branch is calculated. Then it is added proportionally to get total entropy for the split. The resulting entropy is subtracted from the entropy before the split. The result is the information gain or decrease in entropy. In the first table, gain is 0.247 and in the second table gain is equal to 0.029. In third table, gain is equal to 0.152. In fourth table, gain is equal to 0.048. Gain Tx is equal to entropy T minus entropy T comma x. G golf comma outlook is equal to E play golf minus E golf outlook is equal to 0.94 minus 0.693 is equal to 0.247. Step number 3. Choose attribute with the largest information gain as the decision node. Divide the dataset by its branches and repeat the same process on every branch. Here in outlook table we have gain as 0.247. So we choose this as a decision node. So we divide dataset into rainy, overcast and sunny. Divide outlook data into rainy, overcast and sunny. Step 4. A branch with entropy of 0 is a leaf node. Step 4b. A branch with entropy more than 0 needs further splitting. Step 5. The ID3 algorithm is run recursively on the non-leaf branches until all data is classified. So this is it. Question number 13. What is pruning in decision tree? Pruning is a technique in machine learning and search algorithms that reduces the size of decision trees by removing sections of tree that provide little power to classify instances. So when we remove subnodes of a decision node, this process is called pruning or opposite process of splitting. Question number 14. What is logistic regression? State an example when you have used logistic regression recently. Logistic regression, often referred to as logit model, is a technique to predict the binary outcome from a linear combination of predictor variables. Since we are interested in a probability outcome, a line does not fit the model. Logistic regression is a classification algorithm that works by trying to learn a function that approximates probability of y by x. It makes the central assumption that p x by y can be approximated as a sigmoid function applied to a linear combination of input feature. Py is equal to 1 by x is equal to p. Assume log p by 1 minus p is equal to b naught plus summation I is equal to 1 to p bi xi. So p by 1 minus p is equal to e to the power b naught plus b to the power t x b transpose t into x. P is equal to e to the power b naught plus b to transpose into x by 1 plus e to the power b naught plus bt x. So probability is equal to 1 by 1 plus e to the power minus b naught plus b transpose into x. So this will be sigmoid z function. We call it z. B naught py0 x is equal to 1 minus sigmoid of z. Sigmoid of t is equal to 1 by 1 plus e to the power minus t. So this is the graph of sigmoid t. Let's take an example. For example, if you want to predict whether a particular political leader will win the election or not, in this case the outcome of prediction is binary, 0 or 1. Win or lose. The predictor variables here would be the amount of money spent for election campaigning of a particular candidate, the amount of time spent in campaigning, etc. Question number 15. What is linear regression? Linear regression is a statistical technique where the score of a variable y is predicted from the score of a second variable x. X is referred to as predictor variable and y as the criterion variable. Y is equal to b naught plus b1 x1 plus up to bp into xp. Here in this graph, blue dot is represented by training data and linear regression is represented by orange line. This is graph of linear regression. Question number 16. What are the drawbacks of linear model? Some drawbacks of linear model are: number 1, the assumption of linearity of model. Number 2, it cannot be used for count outcomes or binary outcomes. Number 3, there are overfitting or underfitting problems that it cannot solve. Question number 17. What is the difference between regression and classification machine learning techniques? Both regression and classification machine learning techniques come under supervised machine learning algorithms. In supervised machine learning algorithms, we have to train the model using labeled dataset. While training, we have to explicitly provide the correct labels, and algorithm tries to learn the pattern from input to output. If our labels are discrete values, then it will be a classification problem, but if our labels are continuous values, then it will be a regression problem. Question number 18. What are recommender systems? Recommender systems are a subclass of information filtering systems that are meant to predict the preferences or ratings that a user would give to a product. Recommender systems are widely used in movies, news, research articles, product, social tags, music, etc. Examples include movie recommenders in IMDb, Netflix, and BookMyShow. Product recommender in e-commerce sites like Amazon, eBay, and Flipkart. YouTube video recommendations and game recommendation in Xbox. Question number 19. What is collaborative filtering and a content based? The process of filtering used by most of the recommender system to find pattern or information by collaborating waypoints, various data sources, and multiple agents. Collaborative filtering is a technique that can filter out items that a user might like on the basis of reactions by similar users. It works by searching a large group of people and finding a smaller set of users with tastes similar to a particular user. It looks at the items they like, usually based on rating, and combines them to create a ranked list of suggestions. Similar users are those with similar ratings, and based on that they get recommendations. In content based, we look only at the item label, recommending on similar items sold. So here in left side we see collaborative filtering, read by both users, similar users, read by her, recommended to him. On right side, content based filtering, read by user, similar articles, recommended to user. Content based filtering. An example of collaborative filtering can be to predict the rating of a particular user based on his/her ratings for other movies and others' rating for all movies. This concept is widely used in recommending movie in IMDb, Netflix, and BookMyShow. Product recommenders in e-commerce sites like Amazon, eBay, and Flipkart. YouTube video recommendations and game recommendations in Xbox. Question number 20. How can outlier values be treated? Outlier values can be identified by using univariate or any other graphical analysis method. If the number of outlier value is few, then they can be assessed individually. But for a large number of outliers, the values can be substituted with either the 99th or the first percentile value. All extreme values are not outlier values. The most common ways to treat outlier values: number 1, change it with a mean or median. Number 2, standardize the feature, changing the distribution but smoothing the outliers. Number 3, log transform the feature with many outliers. Number 4, drop the value. Number 5, first third quartile value is more than 2 sigma. Sigma is variance here.